Integrals involving two rivals. So in this video we'll basically integrate this function where we have two cosine integral functions, and since they are of same type I'm considering them as rivals, because that always happens in the real world too. And if you don't know about CI function, the cosine integral function is defined as negative of the integral from x to infinity of cos t by t dt. This definition is made based on two policies, basically convergence, and that the derivative will just be the cosine itself, the cosine function itself, that is cos x by x. Yeah. Now let's try to solve this integral. Okay. To simplify, if we use integration by parts, just one of them will simplify, not the both of them. Yeah. First of all, let us start simplify this by using the Feynman's technique, and then it's integration by parts to simplify the other one. Yeah. Let us name this integral as I of p, and then we have integral from 0 to infinity ci cosine integral function of px. And please note that p is greater than 1. Ci of x dx. Now if I differentiate with respect to p, what I will get is I dash of p will be integral from 0 to infinity, then ci function is cos px by px, and then since we are differentiating with respect to p, x will be constant, and again it comes over here, and then ci of x dx. And now the x cancels out, so we have I dash of p as 1 by p integral from 0 to infinity of cos px, and then ci of x dx. Okay, now we dealt with this integral just in the previous video, where it could be easily answered using the integration by parts. Yeah, so if I have to do that again, it's just 1 by p. Yeah, let us take this as u. So ci of x and the integral of other is sine px by p. But fortunately, this product goes to 0 in both the cases, in infinity and 0. So it need not be considered. We have integral from 0 to infinity. Now this one is cos x by x, and then cos, and then the other one is sine px by p. Yeah, sine px by p dx. Yeah. Now this goes to 0 in both the cases, which you can clearly see, because at infinity this is 0, at 0 this is 0, and the other values in both cases are just some numbers that isn't too high or too low. And now this is minus 1 by p. Yes, am I getting two p's? Am I getting two p's? Yeah, probably I am. Okay, now minus 1 by p, and then here integral from 0 to infinity. Yes, and we have sine px cos x by x dx. Yeah, now you can just use some trigonometry to convert the product to the sum, and so using trigonometry we get I dash of p is equals to minus 1 by 2p square. This is because 2 sine px cos x can only be converted to this product to sum formula. So that's why now this is sine of p plus 1x plus sine of p minus 1x, yeah, by x dx. Okay, so now since p is greater than 1, we know that both of them are actually p minus 1 p plus 1 are greater than 0. Yeah, and now we also know that if this we have a Dirichlet integral, that is sine ax by x, if a is positive number, this integral is just pi by 2. Yeah, so using this fact we have minus 1 by 2p square. This is pi by 2 plus pi by 2, that is just pi. Okay, now this is I dash of p. We just need to integrate this function to get I of p, and so we get I of p to be, that will just be pi by 2p plus c. Now to find c, notice that if p goes to infinity, ci of infinity is 0, so integral will be 0. Yeah, that's why 0 is equals to, when p goes to infinity, this also be 0 plus c. So we see that c is just 0, and that's why we get I of p to be pi by 2p, pi by 2p plus 0, so I of p is pi by 2p. So this integral of over here, this is just pi by 2p, and that's a pretty nice answer. Yeah. So this was it. The flow was to use first Fibonacci technique and then integration by parts, and that's all the problem. Hope you enjoyed the video. Thanks for watching and look forward to seeing you in the upcoming videos too.